One of the most widely used power tools for carpenters is a table saw. And for this head-to-head, we focused on 10-inch corded job site table saws, portable job site table saws. We're purposely not including the cordless table saws that are out right now because we plan on doing that in another head-to-head later this year. Because several other models are going to be coming out, and we want to make sure we have a good sampling. For this particular head-to-head, we looked at 8 saws. We looked at the Bosch, the Delta, DEWALT, Hitachi, Makita, Ridgid, SawStop, and Skilsaw. 8 saws. Each of these saws have a 15 amp motor, and they are all able to be fitted with a dado set. Originally, you might see that the Ryobi in our pictures in our video. We wanted to include it as a budget-friendly option. DIYers and maybe for apprentices or young guys getting into the trades, but unfortunately we were unable to adapt it to our testing rig, so we pulled it right out of our testing. So again, you might see it, but we didn't include it in our results. If you're interested in anything I say, you have questions, or I didn't go deep enough, in depth enough, it's because I can't cover everything in a video. You need to go read the article at Toolbox Buzz. Specs, testing criteria, it's all explained in the article. Let's talk about evaluation format. Once again, our team put in some serious time and effort to put together an evaluation to hopefully bring you the most comprehensive table saw information that's out there right now. We looked at assembly because one of the things that we thought about was how easy is it to assemble out of the box. So we had the same person assemble each saw, and we timed that assembly. And we did that to see if there were any significant differences to report to you between the models. So our results were the assembly time for these saws ranged from 21 minutes to 48 minutes. We felt that the assembly time was not really a significant enough factor, certainly not enough to change someone's mind whether they wanted to purchase a saw or not. So we moved forward to dust collection. We also did some testing with dust collection, and we wanted to see if there were any significant differences between these saws on dust collection. Well, all these saws are now competing for like 2% it seems. We attached a Bosch dust extractor with new fleece bags each, and we measured the dust collected over a fixed number of cuts. Bottom line, with a good dust extractor attached to these saws, the results are negligible. There's real no difference. So for this head-to-head evaluation, we decided to break things down into several categories. So this is what we did measure and what we're going to report to you. We looked at precision and accuracy. We looked at performance, and we defined that in power. We looked at price, and then finally we looked at ergonomics. For each of these categories, we rank the saws, and at the end we name a winner of that category, but also we rank all the categories to give you the best portable job site saw based on those results combined. Let's talk about precision and accuracy. One thing I want to talk about is in the commercial construction business, guys typically buy a job site saw for each project. That's how it works. And they use it during the course of an 18-month, 24-month project. When these saws hit the job site, they are unboxed, they're assembled, and they are immediately deployed into use. And they start ripping stacks and stacks of sheet goods. And these saws and the tolerances of the cut materials to them with that kind of cutting, it's not very critical. But what if a contractor uses their job site saw for higher quality built-ins and high tolerance finish cuts, like maybe I do on a remodel? In that case, saw accuracy is critical. In this case, if the saw is immediately put into use, success really depends upon the out-of-the-box accuracy of the manufacturer. Or you've got to take the time and you've got to true your saw, which a lot of guys do, and you should. So the quality of the cuts are more importantly, and potentially safety of the operator is going to be a function for a lot of guys as the as-built accuracy of the saw, because a lot of guys just take the saw and use it. They don't tune it up. So we compared the relative as-built accuracy of these test saws right out of the box, right as setup. To assess the manufacturer's accuracy of these 8 saws, we looked at 6 different areas. We looked at table flatness, accuracy of the 45 and 90 stops, blade parallel to the slot, and fence parallel to the slot, and lastly, we looked at blade runout. All right, for flatness. We evaluate the flatness of the table by measuring with placing an edge of a precision ground bar used for for that purpose. And we did it across the table. We used feeler gauges to measure any gaps. We also used a light source. We took measurements in 4 directions, 2 parallel each way, and we compiled a set of data and ranked the results by assigning 1, 2, or 3 to the relative values of the test measurements. We constantly use our 1, 2, and 3 as our scoring. It keeps things very simple for us. Then we ranked the saws for overall as manufactured table flatness. As a point of reference, guys, a typical sheet of paper is approximately 4/1000ths of an inch. So keep that in mind when we start talking about these measurements. Flatness measurements went from absolute 0, perfect, to 9/100ths of an inch. We measured the accuracy, we also measured the accuracy of the factory set 45-degree stop, and we used a digital inclometer. And this device has an accuracy of 1/10 of a degree. We calibrated the inclometer to the table by zeroing it out on that gauge, and then after that calibration, it was mounted onto the blade. It's magnet mount, and we mounted on the blade, and we would basically get our measurements off of the blade. We used the saw mechanism, the saw blade mechanism, to adjust the blade and incline to the points that we needed to, and we went to the 45-degree stop and recorded those measurements. I want to say that on all of these tests, we did everything twice to ensure that we had repeatability of our measurements. That's important, that you can repeat these tests. Most of the saws measured were fairly close to 45 degrees out of the box. But you'll want to do some calibration if you're going to do some finish work. So let's talk about that. SawStop and Makita were perfect right out of the box. Hitachi and Skilsaw, they were close. They were about a 1/10 of a degree, had a 1/10 of a degree deviation. Ridgid was almost a full degree off at 45. So you'll want to fix that before you do any 45 bevels. As far as measuring the 90-degree stop, we used the same digital inclometer. And for this evaluation, both the SawStop and the Ridgid were perfect. Makita, Bosch, and DEWALT were only off by a small amount, 1/10 of a degree. The Hitachi, the Delta, and the Skilsaw, all 3 of those saws, they needed some serious calibration before getting perfect 90. You want that to be right. We used a digital dial inclinator to measure the accuracy of the blade position to the miter slot. This instrument has an accuracy of 5/10,000ths of an inch. As part of the table saw setup, we installed a new Diablo blade on every saw. And to ensure that there wasn't any wobble in these blades, we did not enter into test results and stuff like that, we marked the blade a blade tooth, and we used that same reference point for our measurements. So we measured the front and the rear of the blade. We just rotated the blade and used the same mark. The SawStop had perfect reading right out of the box. The Ridgid needed some calibration, and the accuracy and the safety basically of any saw really depends on the blade being parallel to the rip fence. Since we measured the amount of difference in parallelism between the saw blade and the miter slot in that previous test, we then needed only to look at the miter slot parallel to the rip fence, the parallel between those two, and that relationship, to see if the saw as a parallel relationship between the two made sense, right? So we used those measurements, and we used the same dial indicator to measure the accuracy. And again, looking at that as delivered factory fence to table miter slot. We took those measurements front and rear as well. And again, this is important measurement because if the material you're cutting is pinched at that rear of the fence, you could get a kickback. Kickback is more likely to occur. So remembering again that a sheet of paper is approximately 4/1000ths of an inch thick, the results show that the Hitachi and the SawStop factory settings, they needed a little bit of adjustment for better accuracy. Runout. One term you might hear when reading about table saw accuracy is blade runout. Runout is a term that describes whether or how the outside edge of the saw blade, that outside plane, wobbles while being held by the motor shaft. Sometimes operators measure runout by using the saw blade that they have on that saw. Well, in that case, the very use of the saw blade presumes that the specific blade is perfect or nearly perfect in its flatness, and there's no wobble in the blade or warpness in the blade. Using a saw blade that has any warping at all will not give us a clear indication of blade runout. So to ensure that we did it properly, and and our runout measurements were accurate, we used a Freud calibration plate. Freud manufactures a ground stainless steel plate to a tolerance of 5/1000ths of an inch in flatness across the plate. And to ensure accuracy, we checked our Freud plate on top of a polished granite calibration table. So basically we bought this calibration plate, but we want to make sure it was right. We used the Freud calibration plate on each of the table saws to measure runout. We removed the Diablo blades, obviously, installed the calibration plate, and we raised the trunnion to its maximum position, vertical adjustment. But before measuring runout, we placed a black mark on the calibration plate to give us a consistent starting point for runout. So we were on the same spot of the plate every single time. A dial indicator provided the test measurements, and only this time the units were then read in millimeters due to the small movement. So we had to do some math with millimeter conversions to get our findings. We placed the dial indicator on a starting position of the calibration disc, and we basically calibrated that position on the dial indicator for a reading of 0. We then were very careful to rotate the calibration plate on the outer rim edge so that we didn't do any side-to-side movement or force on that plate that could introduce an error in our measurements. So while we rotated the plate, we recorded those measurements, and we were looking for max readings on that dial indicator. We validated each max reading by running the test a second time for repeatability and being consistent. We noted that as we performed these tests on all 8 saws, the maximum readings occurred at different parts along the plate, which was interesting as we rotated that plate. And the max readings were, the fact that they were in discrete parts of the calibration plate gave us a pretty high level of confidence that the flatness of our calibration plate was true. So as you can see from the chart, we had ranges from 8/10,000ths of an inch on the DEWALT and SawStop all the way up to 1/100th of an inch on the Skilsaw. Typical values of 5/1000ths of an inch are considered good. So both Bosch and Skilsaw are in that range, and they might need a little bit of evaluation, especially if the saw is going to be used for real nice finish work. We looked, so basically if I had to give this a winner, precision summary, who got the precision summary? The winner, it would be the SawStop, followed by Makita in second place, and then Bosch and DEWALT, they tied for third. Why did we take the time to measure as-built accuracy? Right? I know you're asking this question. Why'd you waste your time with this? Why didn't you just fix all the saws to accurate? Well, as we said in the beginning of the section, many of the saws will be used right out of the box. That is a reality. Believe it or not, it is a reality. And while some may not be considered, there are a lot of guys that demand precision, right? So you're either going to take the time to do it or you're not. But more importantly, we're worried about potential safety of the operator. And if they rely on that as-shipped accuracy of the saw from that manufacturer, there could be problems. So we wanted to look at that and see what the various saws and how they compare to out of the box. That's why we did that. Look, you have every option to tune your own saw, and I hope you do. We looked at performance, and for this testing, we looked at 3 different materials to test performance: 3/4 inch AC plywood, 5/4 inch mahogany decking, and 5/4 inch pressure-treated southern yellow pine. And while measuring the saw blade RPM and the saw motor amp draw. So to compare these tests, or these saws, we looked at how much blade speed each saw has under load, and also how much amp draw increases under load. Think about driving a car. Maybe that's a good example. When you drive a car, a more powerful car will not drop as much speed when going up a hill, and the engine won't work as hard, right? So we looked at it kind of that way. Additionally, guys, we also measured decibels during this test because we thought that was a good time to, when the saws were under use. But we included decibels and rated that in our ergonomics section. The first measurements we looked at in the performance testing was blade speed cutting on all 3 testing materials. This test gives us a relative comparison of how much blade speed reduction the motors have under different loading conditions. That makes sense? So, in our opinion, this gives us an idea of how strong the motor gearbox combination is for each saw. So for each test, we also recorded no load speed. So we could use that to capture a relative drop in RPM. in blade speed while cutting all these different types of wood, these 3 different types of wood. We used our as measured no load speeds instead of the published values from the manufacturers. We wanted to use our own. In order to measure the blade speed, we used a digital laser non-contact tachometer. And we use a piece of reflective tape that we adhere to each saw blade just behind the carbide tooth so that the tape would be just above the top of the wood cutting surface, allowing us to capture that blade speed during the cuts. We used a power feeder to ensure that all the material that was pushed through each saw was fed at the same feed rate. So let's talk about the saw speed summary. The saw, or I should say the table saw with the lowest average drop in speed, in blade speed, for each of the tests we performed was the SawStop. Coming in second place was Skilsaw, followed by third Makita. Bosch and Ridgid were fourth. DEWALT 5th, Delta 6th, and in 7th place was Hitachi. We looked at motor amp draw, all right? So another indication on how hard a table saw is working is to monitor the amps, and the amp draw under loading conditions. So we measured the amp draw for each saw using all 3 different materials again, same materials used, and then we recorded at the same time that we were also recording the RPMs. So the performance summary winner for that was Skilsaw. We took all of the data from the RPM and the amp measurements. We added them to come up with a final performance rank. So for each saw, we added up the total percentage decrease in RPMs for each material type, and then we added the total percentage of amps for each material type. So doing this gives us a relative comparison of each saw over the 6 sets of data that we looked at. Our website article has all of these graphs. I'm showing some of them in the video, showing the RPM, the amp draw for each material. So you need to go there if you need more information on this stuff. But the best overall performance in the testing was Skilsaw. The Skilsaw was described by many in our crew as an absolute beast, and the data absolutely reinforces that. Regardless of the type of material, the Skilsaw offered the lowest drop in RPMs and the lowest increase in amp draw. Following in second place was Hitachi, and then DEWALT a close third. Okay, we looked at price. By the way, price is current pricing at the time of this video. A year later I get comments, oh, it's lower than that, it's more than that. Pricing includes the cost of the stand, and they range from low, $349 for the Hitachi, to high, which is SawStop, that's $1,299. But the lowest price doesn't always reflect the best value in our opinion. In this case, the Hitachi is an incredible deal at $349 and was our winner for price and value. This saw has lots of power, it's got a rack and pinion fence and a solid stand. Another really nice value for price, Ridgid. Currently selling for $399, comes with the stand. And then lastly, it's hard to ignore the price tag on the DEWALT at $499, which is a great contractor grade saw, and I've been using one for years. The DEWALT saw has great features, great fence, really good stand. They've set the standard for table saws. Ergonomics. Ergonomics is the science of designing and producing tools that improve our efficiency while reducing discomfort, fatigue, and risk of injury. Ergonomically enhanced tools can include helpful features such as slightly angled or canted handles, riving knives, safety switches, non-slip coatings. With ergonomics, the key things to consider are whether or not the tool eases your work and prevents you from straining in ways that could lead to injury. So for this section, we considered the following factors, rating them 1 through 3. 1 is the best, guys. And we looked at weight with the tool and stand, power switch location, accessory storage, fence. We looked at the adjustments of the blade guard and riving knife, and the stand. And lastly, we also looked at ascending and descending stairs, as well as the height of the stand and the adjustability of it. Oh yeah, and I forgot, we also included decibels. Remember I told you we were going to put decibels in this category. So let's talk about weight. The saw stand combinations ranged from 80 pounds with the Ridgid up to 114 pounds with the Makita. Decibels. The saws ranged from 93.7 decibels to 97.9 decibels. Now keep in mind that OSHA allows 8 hours of exposure for up to 90 decibels, and then from 95 and up the exposure limits start dropping quickly, starting at 4 hours for 95 decibels. So clearly, all of these saws should require hearing protection. We ranked the quietest three saws as a 2, and the remaining saws as a 3 in this category because we felt that none of the saws should rank a 1 because they all need hearing protection. We're waiting for that 1 rating to come out. The Toolbox Buds all participated in the ergonomics, and we all participated in the rankings. And below, I'm showing a table of that here, and it shows our final rankings. An interesting note about stand height. So the crew felt that all of the heights of the tables were fine for doing work, but the Makita actually has 3 settings that you can set for different heights, and we really, really like that. As far as the ergonomics winner, it was DEWALT and Makita, tied. The DEWALT Makita finished first for our ergonomic rankings, followed by a tie for second as well between the Hitachi and the Skilsaw, and then a tie for third for Bosch and Ridgid. These are all very close saws. They're very competitive. Both the DEWALT and Makita built their saw for professional contractors in mind, and that is clear to me. Overall, the entire crew really liked any of the saws that had the rack and pinion fence system, and that rack and pinion is just a nice repeatable fence. It's just easy to use. The Skilsaw, really large wheels for maneuverability, it was a big favorite. So guys, who won the best portable job site table saw? Who won everything? Well, choosing the best portable job site table saw wasn't an easy task, but we're confident that we've done a thorough evaluation for you. Hitachi. In a very close race for the best portable table saw, Hitachi beat out DEWALT. Very close race. DEWALT in second place. So third place was Skilsaw, fourth was Makita. It's very interesting though that Hitachi and DEWALT look very, very similar. Hitachi just edged out over DEWALT in performance and price, resulting in its final score. Skilsaw beat out Makita for third place, only slightly, and that result was mostly a function of price. It's interesting to note that if we take price out of this evaluation, the rankings would have been a little bit different. So the rankings would have been DEWALT first place, Makita in second place, Hitachi, Skilsaw, SawStop tied for third place, and then Bosch in fourth, Delta fifth, Ridgid last place. So by the end of the day, price is certainly a factor, at least it is to our guys. What we didn't do in our evaluation is any long-term durability. That time will tell on that, and maybe we'll do a look back on these saws. That would be a good thing to do, because that could affect your purchase price too. If you knew the saw was going to last longer, you pay more for it, it'll last longer. We really should point out a big deal here, and that is the SawStop with its flesh sensing brake technology. Look guys, it is hard to put a price on safety, and while the SawStop it costs 3 times what the Hitachi costs, it does offer safety that no other saw can do in these tests. You got to ask yourself, what is the price of a finger lost, a lost finger? So for those that can afford the additional cost, that feature alone may tip the scales for you. Regardless of the price, though, regardless of that price, SawStop came in 5th place for the other categories that we evaluated. So final thoughts on this whole test. These tests and evaluations are very difficult to do. They take a ton of time, months. And ultimately, we're limited in the scope because we're not a professional testing company. You have to trust that we try to do things with integrity and as fair apples to apples as we can. We can't do long-term durability right now because it just takes too long. And we can't possibly test every application that you might want to see on these saws. However, we feel comfortable that all of these table saws in this head-to-head are good saws, and our testing helps bring to light the pros and cons of each saw. Ultimately, everyone needs a tool. You need to choose a tool based on your specific needs, use, and budget. With all of the data that we've done here, we feel confident that you can make a better educated decision on which saw to buy or what saw to buy on your next portable job site table saw purchase. I'm Rob Robillard. Thank you for watching this head-to-head evaluation, and if you enjoyed it, please consider subscribing to the video channel below. Take care.